Okay, we're out here doing an AC tune-up for 2 systems out here in the northwest up by Lone Mountain, behind Lone Mountain. So what we're checking now is refrigerant pressures. We want this needle here in between 40 and 50 in the pink. That's the temperature of the evaporator, right? So it's a little over 50, so we're gonna let it run for just a minute. We want it to be closer to 40. Why do we want it closer to 40? Because that's where it should be for the temperature outside right now that it is. It'll probably slowly come down, and as it looks like it is, it's coming down. This one must be for the upstairs. It might be a little warm upstairs, so as it gets cooler, this is gonna come down. So we're gonna check the refrigerant pressures. That's what we're doing. We're gonna check the capacitor. We're gonna check the fan motor amps, compressor amps. Okay, so we don't know what we're gonna open up to. It could be scorpions, it could be anything. You never know. Gotta be careful. So as this thing's ran, it's come down to where I'm happy with knowing that it does not have a refrigerant leak. It's not low. It looks like it's okay. So I'm going to take this with my gauges off because I know it's good. So we're going to check the fan. This is the condenser fan motor. We're going to check the amperage. Compare it to the data plate. The fan motor amperage should be 0.50. If it's any more than that, we'll possibly have a motor starting to go out. Let's see what it reads. How do I know which wire it is? I'm going to change that to amperage. It's going to be this brown wire right here. This is live voltage, so you got to be careful. I'm going to loosen that wire up a little bit. And it's 0.51, so it's right on the tip of where it should be running. Now we're going to check compressor amperage. Compressor amperage can't be any more than 10.9. I mean, it can, but it's struggling. 10.9. How do I know which wire? It's the blue one. Usually blue. On Carriers and Bryant's, it's usually blue. Any other brand, it could be a different color wire. How would I know which one it is? I would follow it back to the compressor. So I'm going to check amperage for the fan, or the compressor. It's running at 4.24. About right. So the compressor's okay. So fan motor's a little high. I mean, it's right at the tip. We're not going to replace it or recommend it until, it's much higher than that, or that's not spinning. A lot of the times, these motors will start leaking oil. This one looks kind of dry, so it looks okay. I'm not going to recommend it. Pull the service disconnect out. We're going to check voltage here. VAC. We all know we took the power out up there, but we have to verify for sure that there's no voltage. We don't want to get electrocuted. So you take your meter and your sticks, you go down there, and you want to make sure it's at 0. It's at 0, so we're not going to get electrocuted. There still is voltage right here on the side of the contactor. That's your 24 volts. That comes from the furnace in the attic. So you still have voltage, but nothing to be that concerned about. Next thing you want to do is we're going to check this capacitor, dual capacitor. So there is still energy in here, or voltage. It's like a large battery, so you have to discharge the system, the capacitor. So how do you do that? Don't touch the unit because you're part of the circuit if you do. So you want to take something that's insulated and short it out. Just touch the leads together. A few seconds. Okay, should be good. So this capacitor is rated for 35 microfarads for the compressor and 5 microfarads for the fan motor. Fan motor is brown wire, blue wire is Herm or compressor, this yellow wire is common. I'm just going to pop these off. Okay, move these to the side. You don't want them to touch the capacitor when you're testing it. Going to move over to MFD. The little magnet on the back that holds it. So you're going to go from common to Herm. And it should be close to 35. 33.14. So we got to do the math on that to see if it's within plus or minus 6%. I think it is, but we'll do the math. Now we're going to go from common to fan. Let's see what we got. We should have 5 or close to 5. 4.52. I don't know, I have to do the math, it's a little weak. So we're going to put the wires back on, we'll do the math. If it's out of range, we'll recommend it. This is one of the most common failures AC units. 80% of AC failures are all electrical. All 80% of AC failures is electrical. So next part of the AC tune-up, we're going to dust this out. Obviously, dust doesn't really matter that much, but we want a clean environment here for everything, right? Sometimes there's a lot of cobwebs and stuff in here that get caught in the contactor right here, so we don't want that. So that's why we dust it out. Get the top up here. And then sometimes we come through with a rag to wipe down the wiring. Always double check the voltages out. Now you can see the colors of the wires a little bit better. Okay. Now this is your low voltage wiring from your furnace. You always want to make sure these are tight and not chafed. That's why there's a rubber grommet right here, so this wire gets chafed a lot, and once the bare metal touches the copper wire, it'll short out and you have to get in the attic and replace a fuse. So next thing you know, it turns a small job into a big job. Then you're going to want to make sure you tighten your electrical connections on your contactor. These loosen up quite often, so you want to make sure that they're tight. So if you have, when you're testing voltage down here, VAC, you have 240 volts coming in at the bottom. Obviously it's off right now, but if you have 240 volts coming out at the bottom, you need to have 240 coming out of the top, right? The load voltage. If you have a 3 voltage drop, your contacts are starting to get burnt and you need a new contactor. This is like a switch, a light switch. It turns power off and on to inside the unit to outside of the unit. Or, you know, turns the power from here to tell all the components to turn on. So I'm not testing it right now, but we can actually test it real quick. This is all back on. Let's plug it back in. I'll show you. The compressor went in. So now we'll test voltage on the bottom down here. At 247. Kind of high. I haven't seen it that high in a while. Seems high. Should be 240. 247. Wow. 247.8. So it's okay, but it seems kind of high. Usually you see they're like 243, 242, 247's hot. It's weird. But anyway, the contactor's okay. Refrigerant pressures are okay. Fan motor amps are a little high. Just tell them to keep an eye on it. I don't want to replace a part that's not bad, but it's see how old the unit is. How you can tell on carriers is the serial number. This unit was built in the 25th week of 2016. Okay, so almost 10 years old, right? On a lot of the units, you can tell it is like that, but some are not. Like Yorks are kind of hard to read, but most of them are like that. So this unit here, only thing else we're going to do is make sure the math is good on the 35/5, plus or minus 6%. If this is good, because it was reading 33.14, I believe. We got to do the math to make sure this is good, because when clients call us for a tune-up, they want to know how their unit's doing, right? They don't want to be, oh, everything's fine. No, you're here to tell them whether they want to replace things or not. You got to do your job, just like going to the doctor. They're always going to tell you, hey, you know, your blood pressure's high. You got to start eating some broccoli and some salad and some grilled chicken. We're over here to tell them, hey, your capacitor's bad and your unit's struggling, or your refrigerant pressures are low, or your fan motor amperage is high. You let the client make the decision, because you wouldn't be doing your job if you just said everything is fine, you know? Now, anything could fail at any time, just like a heart attack. You can die at any time, right? But at least we told them, brought it to their attention, so they can make the informed decision on how they want to proceed, right? That's what we need to talk to the client about, right? So this unit here, the previous one, the capacitor is a 35/5 and it's reading 18. So this capacitor is toast. It's bad. This one is not as bad. I'll do the math though. But that includes the tune-up. Now the only other thing we're really going to do is rinse out these coils. The dirt is getting sucked in here, and you can see there's debris in here. You know, you want as much free airflow as you can get through here. This is where you get your efficiency from. So we're going to rinse this coil out with water so this unit runs cooler. And so that's our next step on these units, and I'll conclude the video here.